Hello and welcome to this special webinar of the Printed Circuit Engineering Association. My name is Mike Buteau and I'm the president of the PCEA. PCEA is an international network of engineers, designers, fabricators, assemblers, and anyone related to printed circuit development. Our mission is to promote printed circuit engineering as a profession by encouraging and facilitating the exchange of information and the integration of new design concepts through education, certification, communications, seminars, and workshops. This is facilitated by a network of local, regional, virtual, and other PCEA affiliated chapters and the support of our sponsors. PCEA is the producer of PCD&F and Circuits Assembly magazine and the PCB East and PCB West conference and trade shows. PCB East this year takes place June 4 to 7 in the Boston suburbs and features more than 75 hours of technical sessions with leading experts in printed circuit design engineering, fabrication, and assembly, and the top suppliers in the industry. Find out more at pcbeast.com. I would like to thank the PCEA corporate members and sponsors, whose logos you see here. Today's webinar is a departure from our typical format. We are fortunate to assemble a group of esteemed technologists and subject matter experts for a special panel to discuss the future of AI. These domain experts will offer a snapshot of where we are, what's feasible, and the forecasted timeline for implementation. Allow me to introduce our panel. We have joining us, we hope, is Tomide Adesanmi, who is the co-founder and CEO of CircuitMind, a venture-backed startup that is developing intelligent software for electronic engineers. CircuitMind software enables electronics teams to design faster and better by specifying their input requirements and exploring automatically generated design options in seconds or minutes. Before CircuitMind, Tomide was an electronic systems engineer at BAE Systems, where he developed heads-up display systems and helmet-mounted display systems for jet fighter pilots. He made the Forbes list of 30 under 30 Europe manufacturing and industry in 2020. Also with us is Taylor Hogan. Taylor is a distinguished engineer at Cadence Design Systems. He previously held roles as senior architect at Cadence and engineer at Sigrity and Zynetics. He received the 2016 Cadence Achievement Award, the company's highest employee honor. He has degrees from the Rochester Institute of Technology and Georgia Tech. Kyle Miller, Ph.D., oversees the research area for Zuken in Bristol, UK. He is responsible for many future technologies. He has a background in electronics and software and has experience in mobile software development, embedded software, and PCB design. He has developed neural networks for control in the chemical processing industry. And having worked in EDA for 26 years, his current work focuses on cutting-edge developments, such as utilizing AI to revolutionize customer processes for PCB design. He calls himself passionate about all forms of engineering and science that affect humanity, with a particular interest in environmental, quantum computing, and AI. Sebastian Schaal is founder of Luminovo, a SaaS provider rethinking processes within the electronic supply chain. He holds master's degrees in electrical and computer engineering from TUM and from Stanford University, where he focused on management and machine learning. He worked for Intel and researched NILM algorithms for the energy sector before transitioning to deep learning working for the deep tech startups Navviz, and Magazino. Sebastian also worked at McKinsey, focusing on IT and data strategy before founding Luminovo. Over the past 30 years, Dave Wiens has held various engineering, marketing, and management positions within the EDA industry. His focus areas have included advanced packaging, high-speed design, routing technology, and integrated systems design. He is currently product manager for the Expedition portfolio of products for electronic systems design at Siemens, and his degree is in computer science for the University of Kansas. Our moderator today is Phil Marcoux. Phil has co-founded and led 3 electronics companies and has been a technical advisor to many others. He is co-inventor and owner of over 38 issued patents in various chip packaging technologies and a prolific author. Recent consulting projects include automotive electronics, medical device development, and AI-based electronics inspection. The question and answer function is activated and may be accessed in your control panel. Please feel free to submit questions at any time. Questions will be answered at designated times throughout the presentation. Attendees are automatically muted and the speaker cannot see you. The chat function is not active, so you will not be able to communicate with other attendees, just the speakers. At the end of the webinar, you will receive a short survey. Please help us by completing it. I will now turn this over to Phil and our panel.
Thank you very much, Mike. I am in awe of the amount of attendance that we're having and the span of countries that the attendees represent. I'm also in awe of the topic. This is pretty daunting. But first, I want to acknowledge Mike Buteau and the accomplishments he's made with the PCEA in the short period of time that this organization has existed. I mean, this is pretty impressive. And I'm really appreciative of him giving me the opportunity to participate in yet another inflection point that I see in the electronics industry. AI to me is kind of baffling, and I think the panelists that we have here is going to do a great deal to help myself and hopefully the attendees understand it. There seems to be some disagreement as to exactly what AI represents, so it'd be nice to get some clarity on that. In my own experience, spanning 40 years now in the industry, doing manufacturing, which encompassed implementing some of the earliest forms of AI, I find that I think the current stream of AI represents 2 different genres. The generative AI, which I think the panelists here tend to represent. But then to me, there's an older version of it, which we used to call statistical process control, which to me is kind of a predictive version of AI. And at least one of our panelists here, Sebastian, I'm going to put him on the hook to be the first answer the first question. I mean, would you view, well, first off, I want to give you an opportunity to profile for the audience what your product and company does, and we'll do that for the other panelists as well. But would you view your product as predictive or generative or a combination of both?
Yeah, thank you so much for the introduction. So maybe, yeah, on quick 2 cents on our company. As already said, we are a software company focusing on software solutions for the electronic supply chain. So we're kind of catering this to buyers and sellers. So for the kind of electronics OEM, we help their design and procurement teams to kind of optimize costs and risks on their designs, optimize spend and run the yearly negotiations, and orchestrate demand and inventory across different sites, so more on the supply chain management side. And for the OEM and for the EMS or PCB suppliers, we help their sales and procurement teams to automate their quoting and help them can launch a customer collaboration portal so that they can engage in a new and effective way with their customers. So on your point, in my view, I think there's kind of 3 different modes on generally on AI, how it can be used. One is the analytical AI, so where you have like a process or something where the machine does a task normally that's analytical that normally a human could do. Then there's this generative AI approach where you're generating new things, right? It's more this creative part, could be images, could be text, could be like a design. And then you have this kind of forecasting predictive mode where you're kind of looking into the future, trying to predict a future event that might or might not happen. So I think these are always the kind of 3 modes. when we look at our, so we are like more on the downstream side. The other panelists are more, I would say, like upstream in the whole design to manufacturing process of electronics. I think the creative side on top, there's a lot of opportunity for more generative approaches. On our side, it's more the analytical and potentially the kind of predictive and forecasting part. So the analytical part is really about, there are a lot of manual processes today about processing data, could be bill of materials, images of Gerber files, could be PDF documents, where just normally a human have to type that flow, and the machine can kind of by now do that for you. That's basically the big analytical part. There's this decision support, I would say, part, which is a little bit analytical and has some predictive elements to it. And then I think then there's this clear forecasting motion where you try to kind of look into the future of supply and demand trends, forecast a little bit where prices are going. That's a field where I'm always like, from a product perspective, trying to position this as very much like indicative, because no one of us can predict the future, right? You can only find patterns in the past that might give you a good idea of what might happen. And I think products that are focusing on that too much and are basically trying to sell you on that value proposition are sometimes a little bit not very integrative, because I think it's you can have trends. On the analytical side, it's way more, there's a ground truth answer, and the machine can basically just take that workflow off from a human being. So that's my view on the three domains and how we fit in.
Great, thanks. So you mean that email that someone sent me that there's an app that would predict the latest lottery number using AI? I probably should ignore that one. Okay.
Yeah.
Yeah. Let me go right on to the very top of the upstream. Taylor, I'm going to give you the opportunity to profile, what Cadence does, and I view you folks pretty much at the very very upstream end of things.
Sure. My name is Taylor Hogan. I work for Cadence Design Systems for about 12 years now. Cadence does electronic design automation in lots of different domains. We're getting more into system design and flirting with molecular simulation. My particular team started about 5 years ago from a generous grant from DARPA to generate printed circuit boards with no human in the loop. And the team has sort of evolved from that. We're all based mainly out of Boston, mainly from New University graduates. And we're basically using a little bit of AI to automatically generate printed circuit boards, sort of in the theme of what the IC industry has done with automation, we're trying to do with printed circuit board design.
But you would consider what you're offering as pretty much the generative side of AI, correct?
At the very top level, it's generative in that we're generating designs, but we do that through, in the vernacular of AI, through a value network, which is evaluating the goodness of a design across multiple domains. So we are using things like genetic optimization and Monte Carlo tree search to basically find and generate designs, but they're being graded against I think somebody used the term stochastical or neural network that's been trained to quickly evaluate the goodness of the design in different domains.
Great.
Not sure where that fits in with current literature, but that's what's going on underneath the hood.
Great, thanks. Kyle, let me invite you to talk about Zuken and how your product may be differentiated.
Sure. So I could pretty much copy and paste Taylor's response, to be honest. But so Zuken is obviously EDA, Japanese EDA CAD vendor. It's been around for close to 50 years. Scarily, this is my 27th year with them, so I've been with them longer than half the time they've been around. And most of that time I've worked in automation, so traditional automation like auto routing and auto placement. And a few years ago, pretty much the similar sort of timescale. 5 years ago, obviously AI was becoming quite big. We set up a team to to look at the feasibility, first of all, of using AI in PCB, and that's now become our main pretty much our main focus in Bristol. It's one of our main areas we're working on. So we've put quite a lot of resource into AI, mostly in PCB. Although Zuken has other products like wiring harness and systems engineering, things like that. And we released just a sort of an early eval version of an AI-based auto routing system last year, and the first sort of publicly available version of that is available in the next few weeks. In fact, final confirmation was pretty much today. So it's been a pretty busy day for me so far. But I'm looking forward to that being out within the next few weeks. So.
Wow.
Very
Would
cool.
you, now you'd consider your product in the generative class as well?
Yeah, exactly the same. You know, of course, you're generating information, but as part of that, you have to evaluate how good the quality is. Exactly the same thing, you know. And then, you know, one of the things we're also trying to do is use a style. So it's not just about quality in a sort of numerical, you know, quantitative sort of way. It's also qualitative in that, you know, we're trying to extract information about style and, you know, user preferences and things like that. So it's not just strictly just looking at the numbers. It's also looking at some, you know, sort of aesthetic parts of the design process as well. But both generative and analytical parts. You
Great.
need that in order to generate something. So yeah.
Right, right. Good. Thanks. Tomide, are you able to hear or converse with us? I see that you're
Yeah,
on.
so can you hear me?
I can. Let me invite you to come on in a second. I want to give David a chance to talk representing Siemens, and I'm going to profile him as the hat trick in the group because I view him as representing three different aspects of or products for AI, and I don't know if he wants to present all three, but nonetheless, Siemens seems to be amassing quite a collection of products here. David, you want to take an opportunity?
Sure. Yeah. I just to be clear, I represent the design side of the house, but coming in from the Mentor Graphics acquisition. But one of the amazing things, you know, being a part of Siemens, is collaborating on a daily basis with the folks that we all, you know, as EDA vendors, we've always, you know, had to work with PLMs, with MCADs, and simulation companies. Manufacturing, that's all hanging out in house here, and so it's a synergy that is wonderful to participate in, and it's a synergy that in the case of AI we believe will be leveraged to great strength. You know, within Siemens, you might know it's kind of a big company. It's got over 300,000 people, I think, and within that, the number count on AI experts is hanging out over 1,000. So that's within corporate technology groups, that's within product lines, it's all over the place. And part of you know, part of the fun is leveraging that technology to a common end. We all know there are capabilities within Amazon, you know, AWS, Microsoft, others. Within Siemens, you know, we have internal stuff as well. So we're looking at that as internal work, you know, internal engineering, as well as the more public ones. As far as products that have AI, today Hyperlinks has AI under the covers for doing design space exploration. That one's definitely in the generative camp. Looking at all of the possible, say across the SerDes channel, looking at all the possible permutations, layer stack ups, spacing, thickness, you know, everything, you know, via structures, and determining the optimized solution. AI inside, you know, supply chain resilience. We've got through Supply Frame, where they're actually looking at what you might call the digital exhaust of over 2 million people, you know, engineers searching for parts daily, and that's definitely the, you know, in the predictive space, trying to understand the trends, understand what parts are popular, what parts might be running out of stock. And that technology is integrated, of course, directly into our flow now. Engineers can have ready access to that when they're doing part selections. And the other one I'd call out is within support. Most folks see this now. When you call or you try to chat with somebody, if you don't know it already, you're going to be talking to AI. We've got that within our own support. And it's not the only way you can talk. You can still talk to humans, obviously, but when you're scanning a vast array of information, say on what we call our support center internally, AI provides the opportunity to narrow down, prioritize the content in a way that minimizes the time. No engineer wants to spend their time searching for stuff, and so AI, is readily available there. AI is also in neighboring products, in X for MCAD, in SimCenter, and like the design space exploration products I mentioned are leveraging SimCenter technology. So it's just kind of one example of leveraging the broader corporate capability to deliver solutions for electronic systems design.
Plus, I know Siemens is doing an admirable job to try to help coordinate a number of the smaller startup companies. I'm familiar with the collaboration you're doing with Arch Systems, and then I might mention the last couple of years I've been an advisor to Darwin AI, and we've had a chance to get introduced to some of the programs. So I mean, this is you folks have a very admirable cooperative effort and collaborative effort, I might add. And from what I can see with the we're going to put Tomide on the spot to address what I consider the elephant in the room. But I think the collaborative effort that Siemens has started, and Mike and the PCEA have talked about the helping add to that. But I think with that collaborative effort, we can help not only facilitate better acceptance of AI, but also the elephant in the room. So Tomide, you have a most interesting product, and we want to talk about. We want to give you a chance to talk about that, and then I'm going to let you address the elephant, which is all this stuff going to take away people's jobs? So Tomide, go for it.
So thanks for that brutal intro.
Yeah, really.
So at CircuitMind, we are focused on the front end of the design process, from when someone gets an idea to when they're finished with their schematic. And so what our platform does is at CircuitMind, we build our algorithmic and deterministic AI-based software that helps electronics engineers go from architecture or a block diagram to a circuit schematic in 60 seconds. And that's mainly focused at helping them to get to market faster, avoid respins, create smaller, cheaper, more power efficient products. And so the way it works is today, an engineer might build their block diagram in PowerPoint or Visio. We've created an interface that allows them to specify their requirements in a block diagram form within this design canvas that is specific for electronic circuits. Then they can specify lower level requirements on those functional blocks. So if you have a memory block, you can specify your memory size, or if you have a accelerometer, you can specify your axis XYZ. Or you can go as far as specifying your part number on a microcontroller. It's really about giving the engineer sort of like granular control on this requirements. And you can also then specify trade-offs as sliders like cost, power, size, supply chain stuff like availability of components or life cycle status. And then click a button, and our deterministic AI then looks at billions of component combinations, decides how to connect these components together, and create all the circuitry that you need to get this design to function properly. So it adds pull-ups, pull-downs, decoupling, level translators, etc., etc. And then the output from this system is a bill of materials, schematic design, detailed verification checks, supply chain report. All of that you can do in 60 to 600 seconds. And that's kind of how our deterministic AI is working. And the main goals here is to make you do things faster, but also do this thing called solution exploration that some of the guys have mentioned, where you can now look at many different design options and optimize for different things. And also finally kind of do this sort of error checks and prevent, issues. And so one of the big things that I've seen, on this question or on this point of, a lot of people look at this and say, is this going to take away engineering jobs? And my first answer to this is, if you think that an AI is going to take the job of an electronic engineer in the next, kind of decade or so, you don't really know what an electronic engineer does on a daily basis. I think that's the first point that I made. So that I usually try to make. So what I'm seeing from our customers is that they're using these sort of AI tools to get answers faster. So I'll get answers and insights faster. So today, if your project manager is asking you, can we stay below this power budget? Should we use Wi-Fi or Bluetooth? Should we, can we hit this BOM cost? That sort of thing. You can't answer that question without weeks of work. And so engineers are kind of using this sort of AI tools to get a full idea of what they can accomplish very, very quickly. And then, of course, they then take that initial design into a detailed design phase and modify things and add things. I mean, the second thing is that the platform, these AI tools are not going to be able to do the most creative things for you, or things where you need to infuse your own design experience. And so the engineer remains the architect. They remain the expert that makes this more reliable for a use case, and they remain the verifier of the design in the end. And these tools help you get quick answers, optimized answers, and kind of do a more thorough job while allowing you to do the more creative parts of the design process.
Great, thank you. Does anybody else want to weigh in on that? The question of job creation, job elimination.
Yeah, so 10 years, it's good to hear you say 10 years. I think I would agree 10 plus years at least. And what I would say is there are probably other engineering industries that are more under threat than the electronic engineer or PCB design engineer. Like software, for example, is probably going to be one of the first ones to go. And it purely comes down to available data. There's lots of examples of code and things like that you can see online and on Stack Overflow and websites like that. But sharing PCB designs, actually the PCB design industry and even the electronics industry might be saved by the sort of lack of people sharing data, because often quite a lot of these AI things need an awful lot of data in order to work properly. So yeah, I think there's other jobs that are going to go before electronic engineer.
I'd also, I mean, within electronics, clearly, we know the number of design starts, the complexity of design, the increasing challenges are going like this, and we also know that our workforce is going like that. The transition in the workforce, the demographics, they're all, Mike talks about them a lot in the pub. And this is an increasing challenge we see. So you can say there's a static workforce, and that, is that at risk? Well, I mean, again, the challenges are changing on a yearly basis. They're increasing. More things engineers have to consider. In my lifetime, what individual roles did, has changed dramatically. Within the industry, that's going to continue to happen. So, do I think it's a risk? Is the design flow going to change in 10 years? Hell yeah. Is it going to change tomorrow? Yeah. It's, we're all talking about technology we've got that's available today. Does that spell the end of engineers? No, I don't see that. They're going to continue transitioning into, in the way they do design, and leverage the tools they've got available. That's what they've been doing since the day of tape outs.
And I think in general, as you said, it's basically what we're in right now is this kind of perfect storm, right? That normal without these tools, because the demand for electronics is ever increasing, the complexity is ever increasing, and the workforce is at best staying stable, maybe even decreasing, right? And the only way how you can basically combat that exponential increased demand in resources is by stepping on top of an exponentially improving tool set. And I think that's on the design side, the same thing as also downstream in the supply side. One of our largest customers basically said, look, like we see that the manufacturing industry, electronics manufacturing industry is continue to grow, but we just can't find the people to sustain that growth. The only way how we can sustain it is by radically focusing on automation. Yeah? So in this case, it's really basically just being able to ride that wave and to participate on that growth, and not even talking about like reduction of staff at all.
Sadly, though, the challenge that comes along with that, because I've experienced that in two of the efforts that I helped lead. One was surface mount, and the other was the chip scale packaging. As progressive as the members of our industry profess to be, change is something exceedingly hard, and particularly when people's jobs are threatened. I might mention that in one of the other volunteer efforts I have, which is an organization called SCORE, we've been using like ChatGPT to help people that want to start companies. And at first, there was a lot of apprehension, but it was amazing how the creation of an outline for a business plan helped people get over, one of the initial humps to get them on the way to start their own companies. So that end of it is starting to move very nicely. Now the other elephant, smaller elephant, I think, maybe it isn't. I'm going to invite Sebastian to deal with this, is the area of getting data. You mentioned that all of these AI tools require data. And one of the presidents of one of your cohort companies likens the data to either a data lake, where you have data coming from isolated sources, or a data ocean, which comes from broader sources. And it seems to me that we're going to have to decide, or customers are going to have to decide, if they want to use a data lake or a data ocean to enhance the quality of the generative and even predictive nature of the product. Sebastian, how are you dealing with the challenge of getting adequate data?
Yeah, I mean, in general, I think you add a good point there. But I think the good thing that we've been seeing, I mean, we already said AI has come quite a long way from you having, when we think about neural networks, to train every neural network from scratch, to now coming to a point where you can use existing neural networks that have been pre-trained and then just fine-tune them with new data, to a point where we're at now when you look at these generative AI models or large language models, where there has been a lot of training already happening with massive amount of compute and time, and the underlying reasoning capabilities about specific domains are already so powerful that sometimes you can already work with a few prompts and instructions and guardrails, and use that kind of base intelligence as a preprocessor to then put something more shallow on top that doesn't require that much of data. So I think that's definitely like an evolution that we have seen. So that means, I think, for some use cases, you can get actually a rather long way being fairly data efficient and not needing that much data as you would have had them years ago. For some areas that are very kind of unique, being in as you said, we had here generating board design and so on. It's of course something that you can use some parts of that technology, but it's in a sense it is a very much an engineering craft of putting a lot of different models together. And I think there it's always the same. You have to make sure that you get as much openly available data as possible to get as far as you can without having proprietary data, and then basically just making sure that the customer can add some data, and that's then really adding value to the use case. So I think this idea of generally you need more data and so on is only partially true, right? There's per use case, the incremental additional pieces of data you have to really look in, is this actually increasing the value of the specific use case that you are solving? And just looking at just some of the cases that we have is where when you think about like processing bills of materials or like Gerber data, and you can actually don't need that many samples, yeah, and when to get the model to a point where it actually does what it's supposed to do, and then you can already release it. And I think the main important thing for you to have is like a strategy, how you can, from the field, where you have like the policies in place and the anonymization strategies in place, where you can, from the field, do kind of an exception mining, where you're allowed to bring back the exceptions and add them to your data pool to then refine these models. And I think that's the more important piece, is data acquisition strategy for exceptions, rather than like getting that huge treasure on the on the very beginning to even launch anything of value. That's my take.
Great. David, how
Yeah.
that kind of invites a question on security. And since you have your company spans such a broad array of the upscale or upstream and downstream, how do you address the security concerns?
Security comes in a few different ways, and first let me kind of tie into what Sebastian was talking about. One of the ways that we're looking at, you mentioned the manufacturing side, the tech stack that we have to enable manufacturing automation leverages what's called federated learning, where it takes abstracted models from individual factories that the customers are willing then to share. It doesn't have the proprietary information in it, and then that that can be aggregated together to produce a stronger overall model that's then shared back with all of the the different organizations that have participated. So so that's one way to both build a bigger data lake and maintain some level of security. Now, everybody gets to decide, how secure is that? It's in the case of PCB, it's not necessarily just, say the artwork on a board, but how it was created, and what is it that will be communicated, how will it be communicated, and that's so that's a challenge we'll all have to face in terms of convincing our customers to leverage, to share that data and to leverage that data. Additionally, on the security front, one of the biggest challenges that our customers face, particularly at the enterprise level, is cloud access. Cloud represents a great opportunity in the sense of leveraging software platforms in cloud as well as compute capacity. That's really, in some cases, the only way we're going to get to the compute capacity that is necessary for some of these AI engines. But cloud is also, in some cases, in some Milleros, it's blocked off. And so we have to work with with that infrastructure that our customers are willing to deal with, and figure out how to maintain their security, how to maintain the environment that they're willing to work in, to achieve the ends of what we're trying to deliver to them.
Great, thank you. I want to mention to the audience, if you have specific questions, type them in and we can pose them to the panelists. Kyle, what kind of, addressing not only security, but what other limitations are you like your product line being challenged by?
Again, I've just come back to data is the biggest one, I think, from my point of view. But to solve some of that problem, just going back to some of the things that Sebastian and David have said, you can build foundation models with a more general understanding. If you're making a PCB, then it's all physics, right? The physics is the same; it doesn't change. So we're all trying to do the same job. Anybody who's trying to make a PCB is trying to do the same job. They're trying to obey these laws of physics. And if you can build some sort of foundation models that have that same goal, they have that you can use simulation tools or wherever else to check the outputs, and you can actually generate data and then test it to see how good it is. So you can use this sort of generative way to do that. So even if you there are ways around the data the data problem. So, specific challenges, I think a lot of the problems that we're trying to solve are standard engineering problems. They're not specific to a domain. They are, combinatorial problems. They are just classic, difficult maths problems, or there's areas in there where you look at it and go, actually, there's no solution to this. We've worked with universities, and even the university said this work does not exist. This research does not exist yet. So we've had to go through. We've written new techniques for doing things. We've published papers, and just really trying to push the boundary of just general engineering problems as well as the AI. And one of the difficulties that we've faced is that AI in other areas is so successful, or is apparently so successful, and you get things like ChatGPT and everybody tries it and they go, that's amazing, of course it can solve the world. And then you try to apply that to something like any engineering discipline, but PCB in particular, and there's so many more constraints involved in that. I talk about this triangle of creativity, precision, and accuracy, and having to have all three of those things suddenly means that the problem is a lot more difficult than generating an image where it doesn't matter if it's not exactly right, or generating some text where it doesn't matter if that's not exactly right. It has to be accurate and precise at the same time. And that's one of the challenges we've faced, is having that creativity but doing it within a rigid structure that you have to follow.
Great. Taylor, you got anything you'd like to add in that area?
Yeah, just to go back to the data piece, I'm not in the camp where data is that hard to get for the the neural nets we're building. Fortunately, EDA is a virtual world. I don't have to go out and take pictures of stop signs and stoplights all over the world to create a neural net what a stop sign looks like. But I can create millions of design variants for training data. I don't see that as the #1 problem. I'm kind of in Kyle's camp. It's just hard engineering problems. That's what the issue is. And I'll come back to that. But the David is talking about cloud and security. We only run on AWS for the tool, and certainly there are some customers who love that because they don't have to go out and buy hardware. Other customers are very hesitant because, well, it's cloud. It's potentially not as secure. And then I remind them, where do they do their banking? It's up on AWS. But you can run a local cloud and all is fine. I do believe the #1 problem is just engineering problems, and there are kind of two ways to do AI in engineering. You can try to learn the patterns of what humans have done, or you can make it physics-based, meaning you're judging a design not by how it looks like someone else did it, but does the ground truths of physics still hold? We're definitely in the latter camp, and making physics fast is hard. You're not going to run caliber after each run. You're not going to run a electrical simulation. But I do believe you can build a neural network that says, is this design better than that design in a given domain? And you're looking at milliseconds for evaluation.
Although I'm going to invite Sebastian to join me on the manufacturing side of this equation. I mean, so far, David and Kyle and Taylor have sort of represented the design side, and admittedly, using an AI tool to make to produce a PCB faster than what we routinely are able to do is really nice. But then some of us have to figure out how to manufacture that blasted thing. And between the circuit boards that your design product puts out, and the changes that the component suppliers do, and the material suppliers, and then we have the desire of the product people to make everything smaller and smaller and smaller. How do we get manufacturing data that presents a whole new challenge back into the design side? Sebastian, your product kind of opens the door for that opportunity.
Yeah, so from our side, it was also the idea that, okay, how can we motivate basically also manufacturers, being it PCB manufacturers or like EMS or contract manufacturers, to kind of start kind of mapping their design, their manufacturing capabilities in software, such that we can finally build up some form of a network that can then, if both sides agree, also be shared with each other. And we felt that this kind of the quoting workflow, which is like for these like if you're building custom stuff, right? Quoting is like a very essential part of your business, of the sales motion. And in quoting, you have to do this assessment, right? You have to quickly be able to digest information that your customers throw over the fence, kind of reverse engineer that product, and then match it with your own capabilities and see if you can actually manufacture it, or otherwise you wouldn't really be able to quote it, or you flag this to the customer. And I think
Great.
that's been basically our approach, to allow these manufacturers to map it for their own use, for their own quoting workflow. And then if you have like a business relationship where like an OEM and a CM, or even the PCB manufacturer in that triangle, they are working together and they're willing to open those notes, then those profiles can be shifted left into an earlier process. So far, we are not like shifting it into the design tools, but we are rather focusing there on the kind of procurement organization. That's like a tool that the procurement organization uses with an interface where the designers can then upload their files or share it from their design tools, which is then quickly processed, and then you kind of see already that 360-degree view on the supply chain. One, sourcing issues, which already are sometimes shifted left in the design tool as well, but that's something we have as well. But also then the PCB manufacturability, CM manufacturability, and a little bit the should costs on the actual labor that's involved. And that's something that we can provide to the whole kind of design intelligence ecosystem. Yeah.
Great, but I'm delighted to hear you say the third challenge, communication between manufacturing and design. I know in the work that I was doing with Darwin, because they focused on automated optical inspection, and the challenges of being able to inspect a solder joint. We had no idea just how daunting that was, and in particular, with everybody wanting to go to bigger and bigger BGAs and hide more and more of the solder balls where in places where no one ever wants to see them. It would be nice to have a predictive tool to decide, gee, does the designer really want to go to that larger BGA, or should he use a multitude of smaller BGAs and make life easier for the manufacturing team? Now, that requires the ability to communicate the data that was generated on the manufacturing side back into the design side. It doesn't seem like we have a good, easy answer for that. Do any of the panelists have any answers for how we're going to make that communication happen?
Sure, I can take that on a bit. We've fairly recently introduced a product that tries to build that ecosystem. I mean, it's an ecosystem that exists already, let's be clear, between design and manufacturing. We've tried to optimize it a bit to enable design teams to upload their design and manufacturers to be able to upload their rule decks and their availability and other information in a way that enables them to collaborate efficiently, and that's the primary goal. Does that have AI under the covers? No, that's just an optimized, ecosystem.
Now, are you talking about? Is this a Siemens product, or is this
PCB flow?
So not the IPC CFX?
No. This is PCB flow. Now, the opportunity, given much like we've done with supply frame, on the components, ecosystem, doing the same thing on the manufacturing, side is a potential as well. What's the availability look like? What's the cost look like? What's the reliability look like? To your point, if you choose to pick a particular component. So that is something that's interesting as an opportunity.
Great, Taylor. How your product came into existence is interesting, with the DARPA grant and the like. What do you see as the golden ring within our industry using an AI tool?
So I definitely believe that the software is the governing factor of producing new and better PCBs. If the software was better, we could generate more designs quicker for evaluation. So, so my goal in life is to bring the automation of PCB design up to the point of where IC design is today. And I think that's not going to reduce the number of PCB designers or engineers, but it will change how they do their job. Today, when we get a design and try to replicate what the human did, the rules don't correlate with the board. You can't build that board with the rules there. So there was some tribal knowledge about what rules were really important and what rules, weren't. Well, the algorithms of AI doesn't have that latitude to know that. It's strictly physics-based and manufacturing-based. So in order to take advantage of the optimization techniques, I believe the user is going to have to do its job a bit differently, but that will afford, much more productivity. So my goal is to have PCB design sort of in that theme, where you are, I don't think it's going to begin with a click of the button and all magic happens. That's certainly an interesting point. I think it's more like a co-pilot where you're asking for, I'm going to design this. I want you to design that. No, that's not quite right. I want you to do this. So it's more of like a co-pilot. That's an overused term, but I can't think of a better one. So I think that's how it's starting out, and that's certainly how people are using, our tool today, where maybe they're putting down big devices and asking the AI to, place and route the rest of it, or at a global placement level, where these things have to be. It has to be really fast, and it has to be zero effort. You're not going to get a lot of people interested if it's a brand new UI with lots of new things that you have to do. The step function into this has to be really low, and it has to be super fast for it to be to add value. That's what I think. So certainly DARPA's goal was to reduce the number of people it took to make a PCB. They kept saying that they make a lot of electronics, and they do, but if I'm a double E, am I likely to go to Apple, or am I likely to go to the Air Force? You're probably likely to go to Apple. So they have a lot of electronics to build, but not a lot of people to do it. So they're just really hungry for any automation.
Yeah, I love your co-pilot analogy. I think that's very apropos, and I think it, those engineers that are worried about their jobs should take heart and realize that as a co-pilot, it helps strengthen their job. Mike has alerted me that we have audience questions, which I can't see, so I want to invite Mike, since he can see them, to pose some of those questions.
Thank you, Phil. Here's one. Will Moore's law still be applicable? The half time per cost every year, or every second year in many parts of the products or project. It's a little bit, it's from somebody who's in Europe. So it's a little bit unclear, but I think the main thrust of the question is, what will be the impact of Moore's law in the age of artificial intelligence?
Shall I have a go at that one? So, I think what AI tends to do is go forward in jumps. So, sometimes a new technology comes out, like a transformer for ChatGPT, and something leaps forward, and then a load of research is done on that particular new technology that someone has discovered. But it's fair to say, I think, that even people who are general AI experts are surprised by the sort of speed at which these things are happening. So it's hard to say, because again, it just takes somebody to come up with some new way, some new network type, or some new way of handling data, and suddenly there's a big leap forward. So I think I would hedge on no. Moore's law doesn't apply, but because it's too slow.
I think Moore's law will make, making system on a chip that much harder. Chips can't get that much bigger. It's not going to die in my lifetime, but that does now open the opportunity for multi-chip modules, and an AI can explore, that sort of system architecture faster than a human can. What logic goes on what substrate at what cost is really the ultimate question. And I think an AI can mitigate some of the problems with Moore's law is going to introduce.
I'd agree with Taylor. I think, yeah, 3D IC is the carry forward with Moore's law, and the permutations that are currently available for an engineer to consider to achieve that are pretty high, and so leveraging AI to help narrow that to be able to pick the right technology, the right manufacturing partner would be an interesting area.
Mike, any others?
Yeah, several.
Oh.
Data would be easy to find or generate, but would it be that easy to find reliable PCB samples at every level of complexity?
So again, just coming back to Taylor's point earlier, or even when you were asking the question, Phil, about the manufacturing, how do the changes in the manufacturing, how do the problems in the manufacturing get back to the front end, to the design part? And if you need somehow to sort of embed the knowledge and the know-how of what's happening during the manufacturing process back into the design in order to mitigate some of the problems with the manufacturing. So again, that's why I think a lot of it is about data. And I think what we found as well is if you try to give a result that is purely physics-based, then I think you can probably get a better design than a PCB design engineer can do. But will they accept it? If it's not a complete solution, if you're just helping out in part of that design process, you've got to produce something that is acceptable to the user until you're doing everything, in which case then it doesn't matter. But until we get to that point, you have to produce something that looks like whichever part of the process you're doing, it looks like something a human would do, because otherwise they just won't accept it.
I think the greatest joy I've gotten out of this is giving a design back to a user and they're say, oh, I had not thought about that. That's a really interesting approach. And that's when I know things are looking up. That's a good day.
So the thing that I would say is, how do you get that know-how? What is it? What is IP really? And how do you extract that know-how, that knowledge from any area of the PCB process, and take the essence of that and put it into the the earliest part of the design process that you can get it into? That's the real trick.
I think one comment on what you said, Taylor, I think the machines are probably very, very good in creating a lot of different variants in a very short time. But we humans are exceptionally well, like critics. We're not the best generation machines, but we're very intuitively good in making a decision. Is this better or this better? What's the better result? And I think that's, if you think it from that perspective, I think that there's this great symbiosis that can be done. Think about the design. There's like here 3 designs, which is better, and like where you can have a very good intuitive decision. I think that's what you see in many different areas, and there we don't have to threat. Perhaps there's not really a threat, because this like decision, like a gut feeling decision, is really something what makes us special, and I think where we can really build on top of this capability.
Mm-hmm.
Next question. In the future, which specific tools or skills will PCB designers need to learn so they don't lose their jobs? I'd like the panelists to share their opinion and prediction on it.
Wow. Well,
Loaded question.
Loaded question. I guess the easiest thing to say is come at it with an open mind. I think all of us who have been around the industry for a while can point at products we've introduced particularly when automation is involved, that have had low adoption. Sometimes it's because, as we say, that dog doesn't hunt. It doesn't really solve a problem. But a lot of times it's because teams they have their established processes, and frankly they're too busy to consider new ones. And so as a result, opportunity it goes by. I think having an open mind, thinking about AI as an opportunity, not as a threat, is the biggest thing that designers and engineers can consider as they move forward.
Can I weigh in on this?
Oh, please, Tomide. Yes.
Please.
Great. So I kind of have a philosophy on this. So the way I see it is there are two opposite ends of the spectrum, where you can either be a generalist or you can be a specialist. I think if you think about the future with AI, my kind of prediction is that people should go to either end of the spectrum, but try not to stay in the middle. So what does that mean? So either you become a really good generalist, so you can do RF, analog design, digital, write firmware, maybe even do some mechanical CAD, etc. And that sort of engineer is going to essentially be the leader of a bunch of AI agents that go out in the field, do a lot of different things for them, and then they can critique it in kind of thorough, comprehensive detail, and then make a full system, right? These agents are helping you to kind of do so many things and come up with a result. That wouldn't change. You are still going to need those supervisors, those architects, no matter how long this all takes, right? You're going to need those kind of generalist system engineers, I would call them. And then the second kind of the other part of the spectrum is there's some very kind of specialized things that it's going to take a very, very long time before an AI can even kind of break through on any kind of reasonable dimension. So people with, that can route, 30-something layer PCBs with RF signals and, all sorts of sensitive analog stuff, that's not going to be replaced. RF engineers, kind of complex analog, etc. The list goes on. So the way I think about it is if you can put yourself on one end of the spectrum and not kind of, dilly-dally in the middle, I would say, you would probably, you will find, a path to the future, essentially.
Sebastian, did you want?
Yeah, I mean, I think in general this holds true for many disciplines. You have to. This goes a little bit in the direction what was first said. You have to be extremely open to change your tool stack. And I think you've seen that if you think about a software developer, right? There have been so many changes of what's the new hottest tech stack, right? From the MERN stack to LAMP stack, whatnot. And the developers had to kind of change frameworks like constantly. And I think for an electronics engineer, this wasn't that much the case. If you look at the past decade, you could basically work with your tooling and there were new tools, but this was not like the stack is changing every 2 years or something. You could basically work with a new stack for quite some time. And I think that's probably changing. I think this adaptability is something that you desperately need, being able to work with different tools, change, also rethink how you've done processes. I think that's key. No, that's just an outside view.
So my answer to what I think the question was, what is the behavior that needs to be adopted by the PCB designer? One is patience. I spend most of my day asking PCB designers why. Why did they do it this way? Often it's worked before. That doesn't scale, gentlemen. So you intuitively know why, and you may have to work with your hardware engineers to find out, but patience on people asking you why. You're along this sort of road with us with using AI and automation to PCB design. And if you help us, we're going to help you. This is not going to take your job away. This is only going to make you more productive, but you're going to have to give up the notion that just because it doesn't look like something you did, it's not good. So we have to be able to prove that it's good. You know, the first answer is, oh, well, that placement won't route, and au contraire, it routes just fine. You know, it meets all your rules. But indeed, there's usually something there that's not explainable in a constraint manager of why one particular, you know, pattern is better than another, and that's what we need to capture. So it's patience with, you know, the EDA company of asking why did you do it this way? What is involved?
Yeah.
And relax, we're not going to take your job.
I would also give the advice that you know, learn about AI. Just, you know, it's coming, so try to understand as much of it as you can. And you know, that just general advice. But I would otherwise agree with Tomide. You know, specialists or generalists, don't go in the middle.
Yeah, Mike, if I may add, you know, as a business owner, the more that the engineers, printed circuit board designers, manufacturing people, the more they can understand what the customer wants and needs, they're going to flourish. And if they use AI as a tool to help them, you know, get that information out of the customer and back into the product sooner, then that's the way they themselves are going to succeed.
Great, agree.
Here's another question. In fact, we have a few related to manufacturing. PCB fabrication is a low margin business. They generally don't like to hire programmers or buy software. Many of them still use paper and manual editing to create tooling. How is the AI community going to present a business case for them? Just for your information, I am 100% positive that it can make a significant cost down and streamline cycle times. So that's a positive note at the end of that question.
Okay. I mean, I think that's definitely true, right? It's something we've experienced a lot where for people, it's completely normal to pay 100K plus for a machine, but like paying, I don't know, a few $100 per month for software is complete out of the ordinary. And I think that definitely the one big positive is the business model with software as a service, right? Where it's not perpetual sales anymore. You don't have to buy a huge license up front. And the sales motion is also different. People can now quickly do a trial online. They can test it themselves. And I think also where kind of AI and automation comes in is historically these perpetual models, they basically need to be installed, connect to the ERP or to some machinery to provide any value. But like these software like ours is basically ready to use out of the box. And I think that like takes away a lot of the like risks and also upfront costs until that software can create value. And with that kind of change, you can now distribute it quickly, bring it live quickly, training this doesn't take long. So many of these like elements go down and you can quickly write value. And for us, just taking that quoting piece, right? If these businesses don't quote, they don't make revenue. And currently for us, the business case is often pretty easy. Let's assume that CM does 50 quotes in a month and 10 they don't even attempt because they don't have the resources for it. With this tool now, they can do all 60 quotes. Their win rate is normally like 10 to 20%, and that often goes up 20, 30% because they're just quoting faster, higher quality, better data, and better answers to their customer. So there's actually a top line growth. And in addition, there's always a project procurement component embedded in this. And we normally save around 3 to 5% on direct material. And specifically because it's such a low margin business, think about 20 to 30% more top line with a 3 to 5% less spent on cost often comes down to like a 30, 40% uplift in your profits. And that's an amazing business case. And if you are able to deliver that within 6 months on an ROI, then that's like almost comes down to a no-brainer. So I think all these elements together really allow you to present a very strong business case. And that's just one of the use cases.
I'd add a couple things. First off, in terms of improving margins in manufacturing, you know, between design and manufacturing, there's now a clean digital thread to communicate information from one side to the other. It doesn't necessarily, it's not quite as clean going back, and we've talked some about that and some of the opportunities, but just leveraging, let's AI out of the question, just leveraging the digital thread that exists is going to help help manufacturers with their margins. People, we've got awesome formats, ODB++, IPC 2581 to communicate that data, and people are still using old formats, and that requires additional rework in manufacturing. There's cost involved there, delay, respins, everything. That doesn't have to do with AI. That's just leveraging existing technology that exists, existing automation. But one of the additional, the side areas that, that we're involved in is this whole additive manufacturing space. And, I got to say, the combination of AI with additive manufacturing is looking really interesting, just because, I mean, anybody, if you look at, say, mechanical structures, my close cousins over in the mechanical side, the things that they're able to build with additive manufacturing, with applying AI, generative design, they're pretty impressive. And if you start thinking about, applying that to, material selection and geometric creation within design, that's just an additional opportunity to streamline the flow from design to manufacturing, improve efficiencies in manufacturing, reduce materials usage, everything, all the way through the process.
Next question. When doing dense high-speed PCB layout, compromises are always needed. Does your current AI for layout understand the impact of those compromises, and can it make decisions on which compromises are appropriate?
Can I have a slide I could show which would be perfect for this, but one of the things that AI should be good at is taking different constraints from different domains, even manufacturing simulation, whatever it is, high speed, component selection, and being able to find a region in the middle of all that where there's an optimal solution. And I mentioned earlier this creativity. Part of the creativity aspect is which of those constraints, if you don't have a region in the middle where all those domains overlap, what things can I compromise on in order to produce something that is still going to work? And you see this, we see this all the time. This is why automatic tools, traditional automatic tools, have a particular problem, because they generally have to follow the rules. But AI has the ability to go, well, actually, I've seen you've ignored that rule before, so I think it's fairly likely I can ignore that rule again. So, again, that should be one of the strengths of AI, is being able to compromise on those different design decisions and going, actually, yes, the impedance is important for the short distance of track. I can just change it slightly to get through these pins or whatever, whatever the violation is. So that should actually be one of the strengths of the AI.
I also think this is the opportunity of where the tool should not produce one solution, but a family of solutions where some of the objectives were not as good as others, and let the human decide, which one of those is better for them. And then, of course, there's a chance to learn from that. But let's be honest. Let's get a design that's routable, meets SI, PI, before we start getting into things that can't be done. And how do we come up with good designs? So. But I do believe there's certainly opportunity now to not generate just one design, but a family of designs, where all the objectives are somewhere on some curve, and it's really up to the user to pick and choose.
Taylor, your response is a perfect lead into the next question. So you'd use AI as a support, but you'd still have to bring your human expertise and creativity when it comes to compromising, which brings a lot of value for experienced designers. However, it might become way harder for newcomers to make their way in.
Sounds like a great business to stay in. Yes. Well, I do believe there is a large family of designs where they can be done automatically, especially in the the low end, not the enterprise, where they're it's not that dense. So I worry about that side of the business, and I think a lot of designs can be done automatically. It's towards the enterprise size designs where the size and the complexity, it's still going to take a lot of wisdom from an experienced PCB designer to say yes or no. Which one of these do I want? I use AI and software all the time to generate software, and someone just coming in from the software engineer, they're not going to know which one to choose. But I've been doing it for 40 years now, so I can say yes, I like this style better.
Right. And I think, one of the great opportunities for AI is to assist the new engineer that's coming into design, to leverage the skill sets of those who have come before them. And so the question of how do you deal with it when there are multiple opportunities, and can the new engineer deal with that? Well, frankly, you think about it, in the typical onboarding process, you don't present the new engineer with, hey, you've got 20 different ways, figure out which one's the right way to go. You give them a pretty narrow path to succeed with. Likewise, AI can help, with that narrow path, help the new engineer learn on their own without somebody standing over their shoulder. And then as they grow, they can figure out some of those other options. But AI can also, as been discussed, represent multiple options, multiple configurations in a much faster time, and represent those to the user so that they with measures of effectiveness. It's not just, hey, here's two designs, figure out which one you think is best, but measures of efficiency, performance, manufacturability that can help that engineer onboard and learn what's best.
I would like to agree with David on that. That one of the big opportunities for AI, actually in the form that AI, that people are using AI, which is like the chat interface, is this sort of training of new engineers. This idea that you could have 20 designs done by a really great engineer, you have a new engineer on board, and that new engineer can say, hey, give me some information about why the design decisions that the person that did the design did and made, and why they made those decisions. What's off? What's non-standard? And why did they do this? How did they get to this resistor on this kind of interface? Those things are things that today you have to go and sit down with someone, and nobody has time to kind of be teaching you from scratch. But a co-pilot, in the form that it exists today, like ChatGPT, can already at least guess at some of those answers, especially if you train it with your internal data and kind of correct, tune it properly. So I think that's one of the great opportunities of AI as it exists today, not even in the future actually, to kind of help train and onboard new kind of younger engineers.
I'd like to know what % of training data used is a final design that has been validated, for example, past EMI, EMC, instead of just a design generated within PCB layout tools, and how that difference in training data sets results in better quality of the generated outputs.
Are you saying how many designs we generate have been validated? Is that what you're asking?
Well, the question is, I'd like to know what % of training data used is a final design that's been validated. So it looks like they want to know whether a real life end product has been used to educate the AI versus just the tool itself. I think what they're saying is how much of the tool, the learning process was based on real life completed and workable product.
All of it. All the training data was real designs that were out in the field. They're all open source designs, but they're all out in the field and manufactured. So the tool should be able to recreate that and know that it's manufacturable. But we also train on variants of that design, and obviously we haven't made manufactured all those. But it does know when the design meets what the human did algorithmically. So all the training data is real.
So from our point of view, you know, we have our own version of training which generates what we call a brain, which is based on data we've trained internally. But from customer point of view, you know, it's all their data. So it's whatever, we don't use the cloud. All the training is done at the customer site. So you know, the idea is that if they've used design data that was successfully manufactured and is being used, then that's what it learns from. So again, I would say, yeah, from our point of view, 100%, but it's up to the customer.
Will AI reduce intrinsic design risks significantly?
Risk.
I'm not sure I understand that question.
Yeah. Risk of failure, manufacturability failure, performance failure. I guess you could look at it in that context. It enables the designer to consider more potentials rather than just a limited narrow scope. But that limited narrow scope has been created to minimize risk. So I would look at it the other way. I think today risk is fairly low, and what AI provides is the opportunity to consider alternatives, in terms of both manufacturability and performance, that can still yield a design at low risk.
Great.
What piece of advice would you give to young engineers and designers facing the challenges and opportunities posed by AI?
I think it goes back to the previous question. It's be patient, learn how it's learning, and work with the tool. Don't be combative. It's not going to take over your job. So coming out of school today, I think you're going to be using an AI-enabled tool, and you need to work with that tool. If it's not working, then obviously there's something wrong with the tool. But I think a lot of people, afraid that they're going to lose their job, and therefore they're not going to work with the tool. That's not good for anyone.
Many typical engineers and PCB designers are reluctant to embrace advanced techniques by taking advantage of automation and PCB design. Now, with the evolution of AI, how do you see or expect AI to be accepted in the realm of PCB design if automation on its own is getting resistance?
I would say, so go on, Taylor. I was going to say,
not using automation are going to lose, and Darwin's going to take over. So it's a perfect Darwin case to me. Imagine doing an IC design, laying it out by hand, and doing it by schematic. Those people don't exist any longer. So you're going to have to embrace the automation, especially as these designs get more complex. It will be impossible.
Yep, I agree. And I think, again, you're talking about a slightly different approach from traditional automation. And as I said, I've been in this for 20 odd years trying to push automation. And, if people want to do it by hand, they'll want to do it by hand. But if you can show them something that they understand that doesn't look like a machine has done it, I think then that's a completely different story. And one of the things we've seen is, even if you don't complete a design, but if you complete a design enough in a correct way, in a way that a customer can understand, a user can understand it, then they can finish that job off. But if you give them sort of a traditional auto routed sort of board, and they go, well, I wouldn't have done it like that, so I'm going to start again. So I think there's a different level of acceptance of that if they can see familiarity in the results.
And finally, what is being done to help make AI more acceptable and embraced in the industry?
It's everywhere. I don't know if we have to do something, any of us, to make it more acceptable. It's in your everyday life. People encounter AI whether they know it or not. Again, like I was talking earlier, you get on chat with anyone, you're talking to AI. It's something that we can, we all embrace at some level. Some things that are in society today, like ChatGPT, one of the problems is, of course, the reliability of the data. In design, reliability is a much more critical function, and that's where I can say that what we have to do as vendors is ensure that the AI that we supply delivers the right answer. That's the only way it'll be accepted. If we force the user of the tool to verify our AI all the time, they're not seeing any productivity improvement. They're pushing a button and then having to go verify it again, and they might as well do it by hand. We've got to verify that it's accurate.
I'd like to add. Go on, Tomide.
I was actually going to echo something you said before, Kyle, which was until we do it, until AI can do all your design, let's say, I think it's an obligation for the vendors ourselves to help answer the question, how does this fit into my workflow? And that's probably the question I answer the most, because you're kind of bringing people into this halfway house. One workflow, it's not the entire thing, but it's somewhere in the middle, and it has to really fit into the way, the way people work today. And so that's kind of one of the main things that we spend our time on in terms of the UX of our platform, and also when we talk to people and educate them about how to use the platform. Go ahead, Carl.
Oh, I was just going to say, from an interest, we really don't have to worry about the interest, because I think I've never seen so much interest over a product as soon as you put the word AI in it. And from our point of view, we can't get the software out fast enough. Customers are saying, no, we can't wait that long. We need it now. So again, I agree with David. You have to manage the expectations and say, we have to get this right, otherwise they won't accept it, and they will just go, oh, it's another tool, and it doesn't work or whatever. So you have to be good at it. But I think, certainly from my point of view, I've never seen so much excitement in the entire time I've been in the ADA industry.
Yeah, I might comment that just the audience alone actually spans 3 generations. I mean, I've done a couple of inflection points in the industry where maybe we got interest from 1 generation of people or 2 generations. We actually have a high school student who is participating here, and she had actually submitted a video to me talking about some of the aspects of AI she's involved with. I've never participated in an area that spans so many generations of interest.
Congratulations.
So we're going to take one more question and then we'll wrap this up. Will it require AI to be sentient before it can fully design like the world's best designers?
No.
In the context that design is a set of sequential steps, and each step is being attacked one at a time, without being sentient, I would assume that we could string them together and achieve a result without that.
I'm sure we're going to all ask questions in coming years about what sentience actually means.
I was going to pose the question back just to shut it down.
If we get to the point where an AI is sentient, whether it's designing PCBs or not, we're probably in trouble anyway. So, But no, I would say no as well.
I find it interesting that people who are deep into areas of AI like autonomous driving feel they're much closer to general AI than they were before. It's not to say that they're going to need general AI before they do this, but their efforts are leading sort of their thoughts to what one might do general AI. Same thing with large language models. You know, there's rumors around that some of these companies actually do have a sentient AI, and they've done that because they're trying to mimic something, and they just see further than us.
I mean, there's lots of like discussion and research about it, that like how can you prove that it's that it has consciousness or anything like that. I mean, there's this whole, I mean, the concept of like the Chinese room like experiment, where basically if you know, in theory, you send like a letter into a room, like you put it through like below the door, a question in, and it comes out in Chinese, you would think the person in the room can speak Chinese, but they would just have a look up in the book what is exactly the right character to write next, and these people in the room would not have any idea about Chinese, but to you it looks like they do. And I think the same applies to like these models and so on. It will be very hard to prove that they are not just mimicking like consciousness, from what they've seen in scripts from movie scenes, how like embodied AI robots kind of would behave if they would be conscious. And I think it's very hard to prove. I think I had one researcher say something like very, very interesting, that you would have to prove that if you exclude all hints on how to behave when you're conscious from the training data completely, and that system, that then this model system will be trained on it, and then it would show this behavior. That would probably be the only way to see that it came up with those conclusions on its own. But we will probably never train a model like that. It's very hard to prove. So I think by now no one has a real good answer of how to answer that question. Is it just mimicking, or is it really, has it some consciousness?
I think AI is very good at fooling humans into thinking it's more intelligent than it actually is.
Yeah.
Phil, do you want the last word?
Yes. For some of us, that may not be so hard. I don't know if I could build on that one. Yeah, that's good. No, I really have to thank the panelists. I mean, this has been very educational, and I think just judging from the number of people staying on for the extra time that we have shows that this is an area of high interest and high concern. I noted about 4 challenges that you, the panelists representing your companies, have, and representing the user community that we have. So I think the next step, using the advantage of the PCEA organization, is to help try to address some of those issues. And I'm just delighted that Mike, with his effort and expertise, got the PCEA to where it is, so that we can use that as a tool to help all of us on this area.
Totally.
I do want to thank everyone for joining us for AI and Electronics. The listeners will receive a link to the on-demand recording shortly. This webinar has been sponsored by PCB East, coming June 4 to 7 to the Boston suburbs. You can visit pcbeast.com for details. And of course, I want to echo Phil in thanking all our panelists, Sebastian Schaal, Taylor Hogan, Dave Wiens, Kyle Miller, and Tomide and Adesanmi. I appreciate everything that all the time you've made to address the questions. And if folks who are listening have any other questions, you can contact the panelists, or you can contact me at mike@pcea.net. That brings our webinar to a close. I hope you all have a great day. Thank you.
Thank you.
Thank you.
Thank you. Take care. Bye.